So chapter 4 is a bit of a different flavor. We're going to be playing with functions. So the idea behind the construct understanding is I've got two lines on a graph. I'm going to leave the x value the same, but I'm going to play with the y values a little bit, and I'm going to combine them into one graph. Now, your book will tell you what you're supposed to do to combine them, and in this case it gives you a couple of examples that are actually logical, which is handy. So the first one gives us a graph, and on the bottom is years, 2004, 2005, so on. And here is enrollment. So this is actually enrollment in colleges and enrollment in universities. So it makes sense then, if we wanted to know the full-time post-secondary enrollment in Canada for each of these years, I would just add these numbers up and plot myself a new line, because now I'm adding colleges and universities together. So if, let's see, it says function A is college enrollment. So the first function would be this one in your book. Let's call that f of x. So college enrollment looks like, and this is in the millions, but we don't really care. It's just the numbers that are on the graph. So for 04, then college enrollment is about 6. So we're using, this is our x value, we're throwing in our y values here, and we're going to use the y values to find our new y value and plot our new graph. In this case, it's the total post-secondary enrollment. So I go across here, that looks like it's about 6, that one's about 6, this one's a little bit higher, I don't know, like 6.5, not very much. And then we'll go back to 6 again. I don't really care exactly what the points are, I'm just showing you the general trend. Now if I look to university enrollment, it looks like this one's, I don't know, 10.2, and then it maybe goes up to 10.5, and then 10.6, levels off, looks like it stays at 10.6, and then at the end here, this looks like it's at about 11. So now I've got my f of x and my g of x for 04, 05, 06, 07, and so on. 08 is the last one. I don't really care too much about the value in this column. It's just like for this value, these are the two y values for it. And I'm going to add them because it makes sense. Add the college to the university to get the total. So I'm going to go 6 plus 10.2 is going to be 16.2. 6 plus 10.5 is going to be 16.5. Go on down the list, and I get 6.5 plus 10.6. It's going to be 17.1. 6 and 11, 17. So then I go to my graph, and now I can graph over the same x value, so I can use the same graph, and I'm going to plot these new lines. So for 04, it's 16.2. For 05, it's 16.5, so just a little bit higher. Then, 16.6, 17.1, so that would be a little higher still, and then 17 kind of levels off. So then I got my new line that is the combination of these two functions added up to become the total. Makes sense? Now I know how many kids were in post-secondary, whether or not it was college or university, don't care, just want the total. So I didn't deal with my x mathematically, I just used my x to organize my data, and I combined my y values for each x and found a new y value to plot over that same x. This graph is another one where they gave you a realistic idea of what's going on. They have, I didn't label the speed. This is speed, kilometers per hour, and distance. So basically the idea here is that we're checking it for stopping distance. So you've got your reaction time and your stopping distance. So this is the speed that you're going when something happens. This is the distance you're going to travel to stop. This is the amount of time it takes you to react. So your reaction time is going to be, it looks like, you're going to be moving further. The faster you go, the further you go before you react. That makes sense because you're going faster. In the same situation, the faster you go, the farther you're going to go before you stop. But if this is your braking speed, if you wanted to find the braking distance, so this is basically your total here. That's the total amount of time that you take to stop, or the total amount of distance you go before you stop. This is your reaction time. If I wanted to find out the part of that that's actually applying the brakes, I would have to subtract the reaction time from the total stopping time, because you're going to be like, la 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 la, here I go, oh, there's something happening. And then you're going to apply the brake. So the reaction time's already into the equation before you apply the brakes. Your reaction time plus your braking time will equal your stopping time. So if you have your stopping time and your reaction time, in order to find how long, or the braking component, you're going to have to subtract. So all that's just kind of a fun, hey, this is actually realistic sort of situation. What we're looking for in terms of the math is that I'm taking this one and I'm subtracting this one from it. Now there's a whole bunch of points along this line that hit the crosshairs of the graph really well, but there's only a couple that hit this one. So we're going to do it a little bit simpler this time. And I'm just going to take x at 50 and x at 100. So if x is 50, then my f of x, this one here, is 28. And my g of x is 10. Just reading straight off of the graphs. Now the other point that I have is 100. And my f of x, my big one, is 90. And my little one is 20. So my total stopping distance here was 90. 20 of it was reaction time. How much of it was braking time? Or braking distance, sorry. It would be 70. I went 90 minus 20. So I'm just going to plug it into this formula right here. 28 minus 10 gives me 18. So I have two new points that I can plot on this graph and show where the braking distance is. So I go to 50. And my new point is 18, so it's going to be right in there. And at 100, my new point is 70, so this is 60, 70, right about there. And yeah, it's a sketch. So now I can just go, okay, well, 100 and 100, or 0 and 0 are right in here. I want to mess up my pen too much. And go through that point, up through there, and we would assume, that's a garbage line, we would assume that it would follow a nice smooth trend. So I have my line of my new y value over the same x values that I got by combining the y values of the first two functions. Now, I don't think they even give you, no, for C, the third part, they didn't even give you, like, they didn't even try to tell you why you're using these lines. They just say, you know what, multiply one by the other. So they give you this little scenario, and you can see that this function starts way back here and just keeps going. So the domain of the quadratic function there is r. There's no limit to it. But this function starts here and goes that way. So you're constrained by one of them. You can't get values back here because there aren't any values to combine. The only function that exists here is this one. They both don't exist there, so you can't get a value for going f of x times g of x if g of x isn't there. So we're going to start where both of them exist. And I know that my first point is 0, 0 for each of them. So where x is 0, each one of these guys is 0. So my new y point is 0, and I can just say, okay, well, that's where that one's going to start. And then I just kind of looked at your graph and figured out, and you can just read it off the graph. It doesn't have to perfectly hit the crosshairs of the graph. You can estimate. That'll be fine. So this one does hit the crosshairs perfectly at 1 and -1 and 1 and 1. So if my x is 1, my f of x is -1. Whoops. Got a color code. Because that's my y value. And, whoops. Yeah, no, that's right. And then this one is my other function. So that's 1. So then I go -1 times 1 is -1. So at 1 and -1, they're going to be the same again. So I'm just going to draw a line kind of connecting those two. My next one is at 2. Then I'm going to have another one at 3. So at 2, f of x is 0. And g of x is 1.4. No one cares because 0 times anything is 0. So that means that I'm going to have this common line again. It's a sketch, it doesn't have to be perfect. Right, so 3, my f of x, make sure you keep them in order. Follow the line, don't get confused and switch them. This is 3 and 3. So I put a 3 here. G of x, which is this one, is 2.6. And so I'm going to go 3 times 2.6. So that's what? 3 times 6 is 8. Carry the 1. 7.8. So I'm going to go over my 3 line here, up to 7.8, which is somewhere up there. And then I can just make my little line go through here and up. So I've taken my x's to be my sorting numbers. And for each of those x numbers, I've written down the y values that correspond to them. And then I've combined the y values the way it told me to, which in this case is multiplication. I get my new y value right here. I plot it over my old x value. I got my brand new line. Combining functions.